Here is the syllabus basically.
Yes. The syllabus. Yep.
These topics are related to integral, that is SL 5.5 topic number. Here is anti-differentiation with a boundary condition to determine the constant term, and this term is very important for your exam. From here you will get up to 4 or 5 marks. It can be on paper 1 or even it can be on paper 2. Okay, this topics is very important.
Okay.
Okay,
Yes.
okay. Then here is another one, that is definite integral using technology, or there are another topics on definite integral, that is area enclosed by a curve, where you can't, if it is on paper 1 then you can't use calculator, you can't use your ZDC, but if it is on paper 2 you can easily use ZDC. But
GDC.
yeah, but our today's main focus will be on, that is topics number 5.16, that is you are asking to continue integration by substitution. Okay, then we'll
Yes.
go then we'll go one by one. Okay,
Yeah.
okay.
Because Mr. This system my school is following is the Oxford book.
Oxford book, okay.
Yeah.
But I think it will be better to follow Hayes and Harris series.
Oh. What? Excuse me. What did you say?
Hayes and Harris.
Hayes and Harris.
Yeah.
Okay.
Okay. Then we can. I think we can start our lesson.
Yes.
Okay. Here, integration by substitution. Can you identify in these topics, integration by substitution? Here the main important part is to identify which one I should substitute, which function I should substitute. That part is very important. If
Squared plus 3x.
yeah, if you can easily identify the function which one you should substitute, then this method is very easy. Okay, but if you can't
Okay.
identify, then it will bother you.
Okay.
Okay, so here in this integral,
Yes.
can you mark it? Which one we should identify? We
Oh
should
yes. Yeah.
okay, 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 good.
This one in the middle. Yeah.
Okay, then if we let here u equals to, that is x square plus 3x.
Okay. Yeah. So we make u
Okay,
x
okay.
plus 3x.
Then complete it.
Oh,
Okay.
do you want me to write it down or
No, no,
do it in my
no.
book?
You don't need to write down here. Just write down on your copy. Then tell me the result. Okay.
Okay.
But
Yes. Yes. I'll do that.
if you want to write down here on the screen, then it will take more time. Okay.
Yes. Because yeah,
Okay.
I'm slower on the screen.
It's okay. It is easier for me because I am using graphics tab. So, but if you use mouse, then it will. Is it done? Your microphone is muted. Can you unmute your microphone? I can't hear you. I can't hear you. Can you unmute your microphone? Okay. Uh, okay, okay. That is sub power 5. Okay. Yeah, your answer is right. Okay. Now go for first one from here. First one. Yeah. Which one we should substitute here? Or right, right. That is, we have to substitute this one. So u x cube plus 2x. Is it done? Is it done? Okay, okay, then okay, okay, then continue. Okay, you can check the calculation here. I'm doing it. That is du equals to 3x squared plus 2, right? That is dx. So yeah, so the next line will be du equals to, that will be 3x squared plus 2 times dx. Now if we substitute here, then we will have here root over u, that is du, right? Then okay, get rid of square root, that will be u power 1 by 2, yeah, power half du. And then the next line is here u power 3 by 2, then divide by 3 by 2. So yeah, 2 over 3, then u, we have to replace substitute u here by x cube plus 2x, then it will be power 3 by 2, then plus c. Okay, okay, then you are correct. Now can you try next one? Okay, so which one you should substitute here? Good, so it will be u equals to 1 minus x square. Okay, okay, then continue it. Okay, you can tell me, Mr. Farhat. Okay, okay, then just then just match your result with me here. That is du equals to negative 2x dx. So we need here x dx, right? We need here x dx. So it will be x dx equals to negative 1 by 2 du, right? Now if we substitute, then here we have x dx. Okay, what's wrong here? Can you see the screen now? Okay, okay, okay. X, we have here x dx, right? X dx. then e to the power 1 minus x square dx. So we can substitute this x dx with negative half du. Then it will be, so we can put we can put negative outside the integral, then du and eu, right? Okay, so negative half the integral of eu, that is eu. So now we can substitute u, that is negative half e to the power 1 minus x square plus c, right? Okay, okay, that's good. Yeah, so go with first one. Yeah, so from here which one we should substitute? Cosine, good. So it will be u equals to cosine x. Okay, is it done? Okay, what is your result? Good. Okay, it's okay. Your result is correct one. Now can you try number B? Yeah. Which one we should let you? Okay, here let me do it for you. Okay, so now we have here cosine x over sine x. Now we have to integrate this with respect to x. So if we let u equals to cosine, then what happens here? That will be du equals to negative sine x dx. So what happens here? That means here sine is here, sine is here as denominator, right? But To substitute or to replace, we need to sign with dx as multiplier. So if we let u equals to cos x, then we can calculate it. That means we can set cosine as u, so we can set it. That means we have to set sin x as u, right? Okay. Okay. That is ln modulus sin x plus c. Yeah. Okay, your answer is correct. Okay, now from this question we can develop, or we can just see what happens here if we have uh, a function on the denominator, and that is we have here sin x, and numerator is cosine x, right? So if we have a function, rational function just like this, and where if we differentiate the denominator and the result, if we get the numerator as result, okay, then we can directly use this one, or we can directly write, that is ln denominator, that is sin x plus c, right? Is it clear to you? Okay. Denominator, and if we get the numerator, the result of the differential derivative of denominator, then we can write ln f of x, that is this. Yeah, yeah. So this can be write as, if we have a function f of x and the derivative of f of x, that is f prime x and dx, then we can write this as ln f of x, ln f of x plus c. Okay. Okay. So try this one. Okay. Here if you are given that 2x square plus 5, and here if we have 4x dx, then what will be the result of this integral? We can write directly ln to absolute value to x square plus 5 plus c. Yeah. since we have here two derivative of 2x square plus 5 is 4x plus 0, right? That means 4x only. So which is the numerator? Okay, now I think it is okay with you, no? Okay, then go for next one. Here uh, what is the result of the derivative? What is the result of this one? Yeah, chain rule, right? That is ddx of 2x square minus 5x power 3. So if we use chain rule here, then we will get here we can consider this one as x, so it will be we have to apply here power rule, right? If we consider this one as x, so it will be x cube. So if we differentiate x cube, then we have here 3x square. That means 3, what is x? That is 2x square negative 5x square. Then we have to differentiate again. That will be okay, 2x square minus 5. So that will be here 3 2x square minus 5x square, and we have here 4x minus 5. Okay, that is the result of first one, and hence find the integral. We can use antiderivative here. We can use antiderivative here. Have you done it? Are you familiar with antiderivative? Antiderivative, right? Just integral. So we can use here antiderivative. Yeah, same as integral. Basically, what is the relation between differentiation and integration? What is the relation between these two? Right, reverse the differentiation. So that means here, if we consider two terms, 1 and b, if we differentiate a, and we get the result b as the derivative, and then if we integrate b, then we will get a. Correct. So now here, if we look at the term, we have the derivative of this term, that is this, that is this. Okay. So here we are asked to integrate 4x minus 5 and 2x square minus 5x whole square dx. Okay, so we have here this term, right? We are asked to integrate this. Now if we rewrite this as, if we rewrite this at that means we, if we put 3 here, that is 3 4x negative 5, then 2x square minus 5x, okay, and then integral dx, then we can write it as 2x square negative 5x whole cube, right? But there is a problem. We don't have 3 here, we don't have 3 here, right? So we have uh, added 3 extra, that means we have to multiply by 1 by 3. Is it okay? Since the derivative of this term is this, so if we integrate this, then it will be the this will so since we don't have 3 here, that's why we multiplied 3 and then uh, divide the term by 3 also, that is multiplied by 1 by 3. So results is same here. Yeah, we can use substitution here also. Yeah, I'm talking about this because here in this question you are asked to find the derivative, and also at a time you have to find the integral. So since I have done the derivative, so I can use it to find the integral. Yeah, basically this process is called the antiderivative process. Okay. Okay. Okay, where is, okay. Okay, now I think you can solve second one. Okay, then try it yourself. Two, so ddx of sine square x. Okay, then that is 2 sine x and then cosine x. Okay, this is the derivative. No, oh no, there is a mistake here. uh, okay, we have to use this square sine x square. We have to use this square as x, right? Okay, so it will be cos cosine x square then 2 times x, right? Okay, 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 so it is 2x cosine x square. Now look at the integral here. Here we have x cosine x square dx, right? Yeah, we use antiderivative. Then what will be the process, how to calculate it? Since we don't have 2 here, so we don't have 2 here. Okay, so it will be 1 over 2 and then sine x square plus c. Okay, good. Okay, note it down. it done? Hello? Is it done? Yeah, yeah, now I can hear you. Is it done? Okay. Okay. Then, okay. No, 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 you don't need to cancel it. No, 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 no. You don't need to cancel too. Because, yeah, you don't cancel it. Because here we have the antiderivative, that is integral of this value, that is including 2. So if you cancel 2, then that is not correct. So you have to write these 2, and then you have to also keep this half 1 over 2. Yeah, yeah, then integrate. Then the integral of this term is this. Okay. Now go for next one. Yeah, now I can hear you. Okay, now go for next one. This one. Can you solve it? Right. Okay. Okay. Right, right. Uh, are you talking about the difference, first one? So, okay, okay, then you have to use here chain rule. Yeah, 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 yeah. So it will be 5 minus 3x and then plus x square. Okay. So if we consider this one as x, then we have here ln x. So derivative of ln x, that is 1 by x, 1 over x, right? Right? So we have considered this one as x, so it will be 1 over 5 minus 2x plus x square. Then again we have to differentiate 5 minus 2x plus x square. Yeah, 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 multiplied by. So it will be negative 2 plus 2x. Okay, yeah. That means we have here, if we rewrite this, then we have here 2x negative. Oh, sorry, here we are given here 3, right? This one is 3. Oh, yeah, yeah, it will be negative 3. So it will be negative 3, then 5 minus 3x x plus x square. Okay, now if we go for integral, then we have here 5 minus 3x plus x square, then 2x minus 3 dx. But if we notice the integral here, we have here 4. We are given here 4 and here 6. 4 6. So multiply, so we don't need to multiply here, right? That means we have to take common. So if we take 2, then we will have 2x minus 3 by 3x square, 3x then plus x square dx. Then we can take out these 2 outside the integral. We can take these 2 outside the integral, then we can use the antiderivative here, that will be this. Okay, can you complete it now? So it will be 2 yeah x square. It will be absolute value plus c. Yeah, so that is the result. Okay, okay, note it down. Okay, then we'll move to next one, right? We'll move to next one. Okay. Here I will give you this as your home task. Okay, I will give you some example. This one, that is uh, slide number 13, and then okay, then take a picture. Okay, and then okay, then this also. So in our next class we will discuss about substitution method or integrating by parts. Then you have to do these also. Okay, you will have so many home task for the integration by substitution method. Then we'll move to integration by parts. Yeah, yeah. And then after this, do you have any idea about partial fraction? Okay, then we will move on to that, integration of partial fraction. That is this partial fractions. Then we will move to this. So our sequence is next. In our next class, I will discuss about integrating by parts, and then after that, we will move to partial fractions. Okay. Okay, then uh, when you are planning for next class, when you are planning for next class.